So before we dive deeper into factorial design, uh, I I would like to clarify the term variables because this is really important. Variables are the building blocks of any experiment. So if you don't understand them clearly, that becomes really difficult for you to understand the term factorial design. So let's think carefully um, in the next terms we're gonna focus on. Basically, we need to understand what variables and what are the two main types of variables. And in case if you think this is basic, but in many cases, from my experience, even if you know the term, but you really need to relate. So perhaps you know what is dependent and independent, but you really need to relate that to factorial design. So I strongly suggest, even if you come across them, to try to go and understand them again, because that will have a different um, emphasis for our work in optimization. So what exactly a variable? We can think of a variable as something that we can change or vary. That is, of course, is not fixed. So it has a different possible value. So we can think about some examples from everyday life. For example, a temperature. A temperature is a variable. So it can be hot, whatever you, a cup of tea, hot, cold, or anywhere in between. Speed is of course a variable. A car can go slow, fast, or any speed in between. The amount of sugar you add in your tea is variable. So you might add 1 spoon, 2 spoons, and so on. So it's the same analogy in experiments. We are interested in how many variables relate to each other. So if I add more sugar, so does that mean it will make my taste sweeter, so the tea becomes sweeter? Or if you increase the compression force, if we take a pharmaceutical example and increase the compression force, does that make the tablet harder to break? So that's what the factorial design help us understand or discover. So basically it will help us understand the relationships between variables. Now here is the crucial distinction. There are two types of variables, and we really need to understand the difference between them. The first type is the independent variables, and we call them X, often use X to describe them, are the ones that you control. So you are the one who decide their values. These are the cause in a cause and effect relationship. So remember them as the cause. And I give you example here. What you just mentioned is the making tea. So how much sugar you add in to make a cup of tea. This is, of course, is independent because you choose whether to add 1 spoon or two or three. The dependent variable, and we in this optimization series we refer to them as Y, are the ones you measure. So yeah, they are the effect that you are what you want to measure. They change as a result of what you did. So in the same example here, the how sweet is the tea, uh, that means the taste is the dependent variable, and that depends on how much sugar you added. You don't choose the sweetness directly, you measure it. After you, of course, you've added some sugar to the you make your cup of tea. This distinction between dependent and independent is very important. So in factorial design, you set up your independent variables, and then after that you run the experiment to measure the dependent variables. So let's visualize this relationship as you can see here. On the left we have our independent variables x, and like we said, this is the cause and this is what we control. In the middle there is a process. So you are doing basically the experiment, the manufacturing step, and that's what we are studying. On the right, you have our dependent variable. Also, you call it output or y. The effect that we are measuring. So the arrow shows the direction of causation. X causes Y, and that doesn't happen the other way around. When you change X, you run the process, and then Y changes as a result. So if we look at tablets, you change the binder amount, which is, we said, X value. You compress the tablet, which is the process you do, and the hardness Y changes as a result of this of this process and the value of X. Let's look more closely at independent variables. The key thing, you sit down before the experiment and choose what values you're going to test. So you control it during the experiment. When you make the formulation number 3, you deliberately add exactly 4% binder. It's under your control. It changes before you see any effects. So you add binder first, then later you measure what happened. So here are some common independent variables in pharmaceutical formulations. So first thing is drug concentration, how much active ingredient you include, the mixing time, how long you blend the powders for, the compression force, how hard you're going to compress the tablets, the temperature, how hot or cold you run the process. And you notice that these, all of them, you can set, you can control, and you can choose. And that's what makes them independent. Now let's look at dependent variables. The key thing here is you measure. You don't choose what values it has. You found out by testing. So it depends on what you did. The hardness of your tablet depends on how much binder you use and how hard you press the tablet. You didn't choose the hardness, it resulted from your choices. So it changes after you change the input. First you make the tablet, then you test its hardness. And here are some common dependent variables that we often, or you're gonna see often in when you do any pharmaceutical formulation. So tablet hardness, how strong the tablet is, drug release, how much drug dissolves, viscosity, how viscous or thick liquid is, disintegration time, how fast a tablet breaks apart. You notice that all these things you measure after you've done the experiment. Now let's apply this to our tablet example. We have two independent variables. Those are the x1, which is the binder amount measured in percent, and x2 is the compression force that we measure in kilonewtons. Those are both things we control, variables that we control. We decide how much binder to add, and then we set the compression force in the tablet press. So these are the input values. We have one, in this scenario, we have one independent variable, that is the hardness of the tablets, and this is Y, and is measured in newtons. This is what we measure. After we make the tablet, we test how hard is the tablet. The hardness depends on our choice of binder and force. The question now is the factorial design, and the answer is the answer for the question that we want to answer is how do x1 and x2, because those are the input values, going to affect y, which is the output value, or the variable, the dependent variable. So here is the mathematical way we can express what we just discussed. Y equals function or f of x1 and x2. So that means is the function of x1 and x2. In other words, the value of y depends on the value of x1 and x2. So from the name, y depends. So it's a dependent variable on the value of x1 and x2. x1 and x2 are independent variables. Okay, so this is a connection between the inputs x values 1 and 2 and the outputs the y value. So factorial design helps us discover how this function or this relationship looks like. So we will do 9 experiments. We'll collect the data and then use the regression analysis to find this equation.
So why does understanding variables matter so much? As we mentioned before, because it helps you plan experiments correctly. So that helps help you to control the variables and then help you decide and select that so that you end up with the optimum levels. So overall, it helps you to control the right things. So this way you need to keep your independent variables precisely at the levels you chose. It also helps you to measure the right outcome. So for that you need to accurately measure your dependent variable. And finally, it will help you predict what will happen. Once you understand the relationship between x and y, you can predict y for any variable or any value of x. And ultimately, it helps you optimize your formulation. So using this, you can find values of x1 and x2 to get the best value of y. And that is what factorial design is all about. So basically, it helps with systematically testing all combinations of x values to find the optimum y.